Hello and welcome to a new video. This is for good old Algebra 1 and we're starting a new unit about solving quadratic equations. This is the first lesson. So we're really going to take a look at, what does it mean to have a quadratic equation, and then what is kind of the first of many ways that we can solve quadratic equations. So let's actually warm up by remembering a couple of things we already know how to do. This first problem says solve, and it has a linear equation. It's a linear equation because it has an x that's to the first power, even though we don't write the first power because it doesn't have an exponent. We know it's the first power. So anytime we have a linear equation, we just say, okay, I'm going to get x by itself by undoing the things that are around x, that are on the same side as x. So I'm going to subtract this 5 over first and get 2x equals 12. And then I'm going to divide both sides by 2 and get x equals 6. And just for the sake of context for later, what we're saying is that this equation has a value that we didn't know that worked for it, for x. And through this process, we were able to find what that number was instead of having to sit here and basically guess. Because that is always technically, or almost always technically, an option when you're in math, is you can guess if the answer is 10 and check to see if you're right, and you can do that until you find the right answer. But because we use this method, we know that 6 is what should work. So we can say, okay, 2 times 6 is 12 plus 5 equals 17. Yeah, we did it right. So that's the idea of solving a linear equation. The other part of the warm-up is remembering how to simplify square roots. So in a similar way to how we treat fractions a certain way to try to simplify them and reduce them so that they're the easiest to work with, we do something similar with square roots. Because when you're doing square roots, you have kind of two options. Either you are square rooting a perfect square, which would be like a number like 36, that you square root 36 and get 6, because 6 times 6 is 36. Or what you have is not a perfect square, and if you type it into your calculator, you'll get a really long decimal. It's actually square roots like that are called irrational numbers. They go on forever without repeating. So for these square roots that don't work out evenly, that aren't perfect squares, we check to see if they have perfect squares inside of them, because our goal is basically to make there be the smallest number inside the square root as possible. So for a number like 24, that means thinking about, what is inside of 24. We can split 24 up into 4 and 6. And basically, I'm making a factor tree here. So 4 and 6, which splits up into 2 and 3. And once we have it as its prime numbers, we look for pairs of numbers. Because if I have two 2's here, that would really be a 4. And we can square root 4, which gives us 2. So every pair of numbers we have that are the same number, we write outside of our square root. And then once we are done pairing up numbers, the numbers that are left over, the prime numbers that are left over, 2 and 3, go back underneath the square root, and we multiply them together. So 2 times 3 is 6. So square root of 24 simplified is 2 square roots of 6. This is something we looked at in an earlier lesson, so I will try to put that link in the description so that if you just want to look over that some more real quick, you can. So let's get started with quadratic equations. So first off, a quadratic equation has an x squared in it. And so pretty recently when we did polynomials and naming polynomials, we looked at, if what the highest exponent is, that's how we can name, one of the ways we can name polynomials. And so this idea of quadratic comes from that. And this, again, is one of the reasons why we bothered to name these things, is because you can say similar things about all quadratic equations. Like as a group, they do certain things, and that's one of the things we'll be exploring over the next few lessons. So if we see an x squared in an equation and that's the highest power, and there's not anything else in it that's weird, like you couldn't also have a square root of x or a fraction with an x on the bottom or other weird stuff. If it's x squared, if it's got an x squared, it's a quadratic equation. If it has an x squared, it also could have a regular x and still be a quadratic equation. In today's lesson, where we're starting off we're going to just have x squared and maybe a number or two that are in the equation, but we're not going to have a regular x term. We'll deal with that in the next lesson. So let's think about what it maybe is different with quadratic equations by looking at a couple of really simple examples. And I'll even go simpler. If it wasn't squared and we had like x equals 25, we wouldn't have anything that we needed to do. We would already know what x is. That'd be actually a really boring equation. But it would also be really easy because it's already solved for x. X equals 25. Okay? So that would be if this was linear. But what if we have a squared here? What does that mean? What squared gives you 25? Well, my hope is that you can pretty easily think of the idea that, well, 5 squared is 25. And maybe some of you, if not all of you, are also able to think of, well, there is actually another number that when you square it gives you positive 25, and that is negative 5. Now, it's okay if you didn't think of that, but that's something that we're going to want to start thinking about now that we know that that's true, right? So negative 5 times negative 5 gives us positive 25. A positive 5 times a positive 5 gives us 25. So there's actually 2 answers to this equation, which that's the first time that's happened to us that we've gotten 2 answers, right? So that's pretty exciting stuff. In this case, or for this equation, I mean, x equals 5 or x equals negative 5. That means that there's 2 possibilities here. And so if this was some sort of like real world situation, we would be saying, well, there's 2 things that could be true, positive 5 or negative 5. There's a cool way that we can write answers as mathematicians because we like to write things shorter. So because this is a positive 5 and a negative 5, we actually can write it with what's called a plus or minus sign. There's probably like a more like technical name for that, but I've always called it a plus or minus sign. So you put a plus sign over a minus sign, and then you write the 5 next to it. And anybody who's in the know for math will be like, okay, you mean that you have 2 answers actually, a plus 5 and a minus 5. So that's a shorter way of writing it. So you can write it out like this, or you can write it with a plus or minus like this. So that's just kind of the gist of what's happening here. This is the difference that x squared is by itself here. X squared equals 25, but we actually still have something that we need to do, which is figure out what goes there that when you square it equals 25. Now, one of the cool things about that is that we actually can think of it this way. If I want this to not be x squared anymore, I can do the opposite to it, which is square root. And if we do it on one side of the equation, we have to do it on the other side of the equation. Otherwise, we're not keeping things equal. So we square root both sides, and that makes the squared go away from the x, because the square root of x squared is x. And then we square root the 25, and it's just that we have to know that there should be 2 answers here, so we get plus or minus. And that's actually one of the trickiest things starting off with this is remembering that plus or minus that keeps happening. Okay? Now let's look at this next one. So x squared equals negative 25. Essentially, we do the same thing to solve it, where we say, okay, let's square root both sides. So x equals, whoa. What is the square root of negative 25? There's a couple different answers that might suffice here. Usually in Algebra 1, and I'm going to take this approach personally, we say we're not going to worry about trying to square root negative numbers because that gives us a not real answer. So we're just going to say that this has no real solution. And that's because we're trying to square root a negative number. And if you think about it real quick, we just said positive 5 squared was positive 25. Negative 5 squared is also positive 25. We're out of options for numbers that we already know about of how we can square something but get a negative 25. Because doing 5 times negative 5 gives us negative 25, but you can't write that as a squared. A squared is the same number twice. So we're going to say that's no real solution. And then whenever we get to Algebra 2, we will come back and look at quadratic equations again, and we'll explore this idea of what's actually happening here. What kind of solutions can we get from equations like this? But for now, if you see a negative and you're trying to square root it, you should just say no real solution. let's look at some examples. So all of the problems in today's lesson, in this kind of introductory lesson, are going to start with there's an x squared, there's some other numbers, but there isn't a regular x term, and that's going to make things considerably easier. We'll start dealing with there being an x term in the next lesson. So if I look at a x squared minus 16 equals 0, what I'm trying to do is get the x squared by itself. Just like normally we try to get the x by itself. It's just that in this case, once we get x squared by itself, we'll have one more step to do to get the squared to go away. So I'm going to add 16 to both sides, which gives me x squared equals 16. Then I'm going to say, okay, I'm ready to square root both sides, which gives me x equals, I have to remember to put plus or minus because I have to think, okay, there's actually two things that when you square them can give you a positive 16. And then we think, what is the square root of 16? Well, it's 4. So the answer to this is plus or minus 4. And then we'll just keep going. B is a little tricky just because it's uncomfortable, I think. You can actually do this two different ways. I prefer to go ahead and solve for x squared by dividing by 16. And you may be thinking, oh, but that's an uncomfortable fraction. We're going to get that uncomfortable fraction pretty much no matter what, though. So now I can square root both sides, and when I square root a fraction, I just square root the top and square root the bottom as best I can. So this is plus or minus 7/4. The other way to do it that you might have thought of is you actually can square root at the beginning, but because there's some trickiness to knowing when you can square root at the beginning and when there's not, I recommend that you don't do that unless you're sure you can. So the reason we can is because this is multiplication between 16 and x squared. I can't do square root of each side here and actually like correctly mathematically get to the right answer. I can accidentally get the right answer, but I can't do it with correct math. So we want to be careful about square rooting at the beginning is the summary there. But you can technically on this one do that. And so the square root of 16x squared is 4x, and the square root of 49 is 7. The other issue here is we need a plus or minus, and we technically could have a plus or minus on both sides, or we could put it just on one side. But we would divide by 4, and we would also end up with plus or minus 7/4. I prefer the first way, but you know, if you feel like, oh, the other way made sense and you want to try that out and see if it works, then I guess go for it, but just be careful. So example 2, and then there's also an example 3, and these are just basically going to be showing off what different kinds of answers we might get and just reminding us how to deal with solving in general. So here I'm going to add 12 to both sides. Now notice this equals -6. I can't say right now that this is no solution because it equals a negative, because n squared's not by itself yet. And if you notice, when I add 12 to both sides, it actually makes that not negative anymore. So that's kind of nice. That means we do get a solution. Well, it's temporarily nice, because then we square root both sides and we say, well, wait, I don't know what square root of 6 is. I know it has to be plus or minus, but that's basically a decimal. And then we think through and say, well, can I simplify square root of 6? Well, no, because square root of 6 is made up of 2 and 3. There's no pairs of numbers. So actually our best answer here is that, well, from a mathematician's point of view, our best answer is n equals plus or minus the square root of 6. So that's going to seem weird probably at first, in the same way that as we've talked about, like leaving things as improper fractions instead of mixed numbers seems weird at first, but I think you'll get used to it eventually. It's the idea that as soon as I type square root of 6 into my calculator and write down a decimal, I've rounded, and so if I wanted to take that answer and use it somewhere else, then I've possibly introduced error. So it's just us trying to prevent, we're trying to just delay rounding as much as possible to have as little error as possible. And so we're practicing that skill by leaving it as square root of 6. Okay, let's solve this for y. So I'm going to subtract 14 from both sides and get 5y squared equals -10. And then I need to divide both sides by 5 and get y squared equals -2. So then we can square root both sides, and square rooting a -2, that gives me no real solution. Okay, so it's because I'm square rooting a -2, I can't do that. I don't have the knowledge as an Algebra 1 student to know what that equals, so it's no real solution. And someone brought up in class yesterday that, well, couldn't we just leave it as plus or minus the square root of -2? And I mean, yeah, technically we could. And that's actually really, really close to what our answer ends up being whenever we start talking about this in Algebra 2. But yeah, this idea of, okay, we're not getting a real solution, I think is a good one to have. We're getting imaginary solutions, not a real solution. Okay, example 3. Now you may be thinking, 117, how dare you give me such a large number? This is going to be terrible. I can't believe you would do this to me. And then 117 plus 3 is 120, which is divisible by 6. And so then maybe you're like, okay, well, that wasn't as bad as I thought it was going to be. You're welcome. So then I'm going to square root both sides. And that means that I will need to check to see if 20 can simplify. So 20 goes to 4 and 5. There is a way to do this where you say, okay, well, because I know that there's a square root of 4, I can just stop and say, this is square root of 4 times square root of 5 and simplify it that way by square rooting the 4. But if you're not feeling that, you just go all the way to the prime numbers and you say there's a pair of 2's. There's a 5 left over, so this is 2 square roots of 5. I recently explored this idea of simplifying square roots and visualizing them in Minecraft, and I'll do my best to link to that video as well, because it may be that if you're struggling to understand this whole simplifying radical things, maybe that will help you out with that. I don't know, but it might be fun to watch. And you can be like, but parents, I'm totally watching a math video, but you're also watching Minecraft. So it's the best of both worlds. Let's subtract 14 and get 5x squared equals 40. And then let's divide that by 5. My hope is that up to this point, you're like, okay, this makes sense because it's exactly like what we've been doing with linear equations. It's at this point where we have new things happening. So we gotta say, okay, square root both sides. We got a plus or minus. We gotta come over here and say, what is 8 if we simplify it? So make a factor tree. We got 3 2's. So 2 of those 2's are gonna go outside and become a 2. But one of the 2's has to stay inside. So this pair of 2's gives me a 2 on the outside, but the leftover 2. Doesn't matter how you pair them up either. 2 of them turn into a 2 outside. 1 of them stays inside. So this is 2 square roots of 2 with a plus or minus. Thanks so much for watching. This is the beginning of our quadratic equation journey, and it's very, very exciting because we've only really done one kind of equation so far. So we're adding to the types of equations we can solve. As always, please like the video and subscribe if you're not subscribed already. And feel free to leave me a comment below with what your favorite number is, because that would be interesting for me to know. Thanks so much, and bye.